See you again. Today I want to continue our lesson. There's a 3.3 tutorial. So hopefully you are finished. So I show you the answer. That means you can check it. Then you can mark it. Okay, let's see the first one. There's an objective. So the objective, I just show you the answer lah. So you want to ask why the answer is like this. So you can PM me and you snap the photo. So I explain for you. So this one is a 1 until 14. You can check it. Got problem, you also can be PM me. So now I want to go to, it's a structure question. Let's see the question 15. Okay, let's see the question 15. They show a bar of the magnet. There's a hung on a spring that attached to the rheostat. So that means the bar magnet is hang together with the spring. So the spring will vibrate. So the bar magnet is displayed downwards. After that, they release. Okay, so it can oscillate through the solenoid, which is connected to the center zero galvanometer. So that means when they just pull downwards, so you find it, the magnet want to go in the solenoid. Okay, now the first question they ask, what means by electromagnetic induction? Okay, electromagnetic induction means you can find out in the first page of the notes. There's a production of the induced current, then without using the power supply. Okay, you no need to using power supply. How you produce a current? We using the relative motion. So that one we call electromagnetic induction. So you must mention no power supply and also using the motion. Okay, let's see the answer here. Okay, there's a production of induced current without using power supply, but by using the relative motion. So just one mark that explain for electromagnetic induction. Okay, let's see the number 2. Okay, we see here when the bar magnet they move toward to the solenoid. Okay, the galvanometer pointer they will deflected a while. Deflected means what? Deflected means they got induced current, is it? So from here they say explain why the galvanometer pointer will deflected. So we just explain okay, they got current, but problem here, can you see there's a 2 marks? 2 mark that means you say they got induced current, then you need to explain some more why got induced current. Because when the magnet they just oscillate into the solenoid, they will cut the magnetic field line. When they cut the magnetic field line, that means they produce a induced current. Okay, so this was a 2 marks answer. Okay, let's see here. Because the cutting of the magnetic flux, you can say flux, you also can say field line, and produce a induced current. Okay, number 2, they say polarity of the A and B. You need to state. Okay, let's see the A. So that means now when you pull downwards means your magnet bar want to go in. So pull downwards, go in, there's a north pole want to go in. So follow the Lenz's law, A should be the north pole also, because they do not let the magnet to go in. Okay, they oppose the oncoming magnet, after that produce induced current. So from here, A should be north pole, B should be south pole. Okay, so this one's the answer. Then we go to question 16. Question 16, they show you 2 diagrams. Okay, let's see the bar magnet, they push into the solenoid. Both speed is the same, 2 ms -1. Okay, now we're going to see the both diagram. We see what's differences. Okay, first one diagram, you see the number of turn is more than 6.2. Then we're going to see the galvanometer. Can you see the first diagram, the galvanometer deflected bigger angle. The reading is bigger compared to 6.2. So from here, we go to answer the first question. State the physical quantity that represent by the deflection of the galvanometer. Okay, physical quantity they show by galvanometer should be induced current. Okay, we mentioned induced current, we never mentioned there's a current, because this one is the induction. Okay, so your answer is induced current. Okay, let's see the B. Okay, based on the 6.1 and 6.2, can you state the 2 differences that can be observed from the 6.1 and 6.2? Okay, we got 2 things that's a difference. First one, we say about the number of turn. So we do the comparison. First one is the first differences. Number of turn of the coin in the 6.1 is more than the 6.2. Okay, number of coin, number of turns. The second differences is the angle of deflection of galvanometer. 6.1, the angle deflected is bigger than 6.2. So this one is the differences. Okay, let's see here. Number of turns, 6.1 greater than 6.2. The second one is the angle of deflection galvanometer, 6.1 is greater. Okay, this one is the two differences. Okay, now we continue with the 2. Based on your answer B1, explain why these differences will occur. Okay, why you say number of turn, after that the angle deflection will be bigger. Why this one will happen? Okay, so we go to explain about number of turn first lah. So that means as the number of turn you are increased, what happened? The magnetic field cutting by the magnet. Okay, the magnetic field go in, or no, sorry, not cutting by the magnet, cutting by the number of turns. So that means when the magnet just go in, as your number of turn is more, then you cut the magnetic field line is more frequent. When more frequent, that means you produce a more induced current. If you produce more induced current, means galvanometer will deflected with the biggest angle. So this one is an explanation why that will happen. Okay, 6.2, you see that the number of turn is less. Although you go in the velocity same, so that means the flux also cut, but the cutting by the less number of turn. So without it, they produce the induced current also become less. Okay, let's see the explanation. As the number of the turn increases, changing of the magnetic flux also increase. Then they produce larger induced current. So this one, why the differences will occur. Now can we say, when we name about the physics law involved in the 6b2. The question is asked about 6b2. They never ask about the A. They never ask about the okay, A. If I say I just want to refer the diagram, the question say name the physics law, refer the diagram. Your answer should be Lenz's law. But now the question they say refer the 6b2. 6b2, what is that? 6b2 talking about number of turn. Okay, so from here the answer should be Faraday law, not Lenz's law. There's a Faraday law because you're talking number of turn and flux. Okay, now we go to the D. Explain why the direction of the current in the solenoid is upwards. You see the 6.1, 6.2, the current go upwards, is it? Why you know there is upwards? Okay, so from here we need to know is a polarity first. Okay, if you know the polarity, then you're using right hand grip. Okay, so we go and refer the diagram. So can you see the diagram? The north they want to go in. Okay, when the north they want to go in, follow the Lenz's law. The first part of the solenoid must be the north pole. Okay, north pole now is the left hand side. Okay, because they oppose the oncoming magnet. After that, they produce an induced current. So I know the left hand side is a north pole. Then I'm using my right hand grip rule. Okay, when I'm using the right hand grip rule, so that means you point like this. Okay, thumb represent the north, then you point by right hand grip rule. So you find it, your finger is go upwards. Finger is represent the current direction. So from here we go to explain. The current induced because the north pole on the left side. Okay, north pole on the left side and oppose the oncoming magnet. Okay, this sentence suppose they just follow the Lenz's law. After that, we're using the right hand grip rule. The current is flow upwards. Okay, so this one is the answer for D. Okay, then we continue with the next question. There's a 17. Okay, let's see the 17 that show about pendulum bob. Okay, there's a attached to the end of the copper wire. Okay, after that the bob is allowed to be swing between the north and also south pole of the two magnet. Okay, now you go and see the whole situation. Okay, the switch just provide the bob go to swing. Okay, they never provide the current go to the galvanometer. Okay, now we're going to see this part. When the switch is closed, okay, the bob they start to oscillate inside the magnetic field. Okay, now the pointer center 0 galvanometer will deflected to the left and also to the right continuously. So from here, can you explain why this one observation will happen? Okay, why the galvanometer be deflected? So the first part we must know lah, the galvanometer deflected because got the induced current. So the answer is, okay, when they are swinging the pendulum bob, that causes the changing magnetic flux. Okay, because between the magnet, they got magnetic field line. So that means when the bob just cut it, that means they got cut the flux. Then after that, they produce the induced current. Then the induced current will from the bob, they go through to the galvanometer. So that means now the galvanometer, they can deflected. So deflected means they got induced current. Okay, now we go to the B. Can you state the type of current they produce? So galvanometer, how they deflected? They always deflected go right or always deflected go to left? The answer should be left and right, because the bob will go to right and go to the left. So that means they're swinging. So you find the galvanometer will deflected both sides. So this current is called what? We call it as a AC induced current. Okay, there's a AC induced current. Okay, and then we go through to the graph. Then they call you to plot the graph. Current time graph to related to the observation for the A. So this one is an AC induced current. So that means we need to plot up and down. So your graph should be up and down. Okay, so this one is a wave diagram, just like the graph. Then we continue with the next question. That's a D. Okay, based on your diagram above, at which one position the reading of the galvanometer is 0? Okay, we refer the diagram. Which part you find it, the galvanometer will become 0. Okay, we find it, the one is further one. The ping pong ball should be further one. We find it that one should be, cannot cut the flux. So the answer should be N. N is the furthest one. Okay, then we see the answer, there's a position N. So you give the reason why like this. Because the position N is far away, they do not cutting the magnetic field line. Okay, do not cut the magnetic field. E, what type of the energy processing by the bob at the point M? Okay, let's see the point M. Okay, point M, they tell you what energy is here. So point M, that is not the lowest one. They got move up a little bit. So we find it that M, we got kinetic energy and also the gravitational potential energy. Okay, this one is the energy they pose at the point M. Okay, let's see the answer. Kinetic energy and gravitational potential energy. Okay, compare the time taken by the pendulum to stop. Okay, now we compare the time taken by the pendulum to stop between the switch is open and also with the switch is closed. That means you need to compare the time taken. Okay, when you open, then when you close. Okay, what happened for the pendulum bob? And also, the normally we just go to swing the pendulum bob, then you stop, is it? Now they want you to compare the two situations. First situation is the bob oscillate, then stop. Okay, another one is you on the switch, then you off the switch. Then what happened for the time taken? So from here you think about that, which one will take longer time to stop? You use your hand to swing the bob, then let it to stop. Another one is you on the switch, then you off the switch. So you tell me, normally lah, you just common sense to think, if you're using the hand to swing, when first round we swing, we provide all the force. We force the bob to be swing, is it? Okay, after second round when they come back, they lost energy already. Then slowly they finish. Okay, if I using the switch, when I just on the switch, okay, all the current must go. Okay, when I just on the switch, all the current just go. Okay, they go start to swing. Swing must be maximum. Okay, now I off. I just take out the switch. So you find it, the switch, that means they slowly, not as fast as using the hand to swing it. If you're using the hand to swing it, that means you're faster to lose the energy. If I'm using the control by using power supply, using the switch, you find it the pendulum, they still got the charge inside there. That means they will continue to swing, then slowly, then stop. So the time taken should be longer compared to normal. You go to using the using your hand, using your anything to move the pendulum to swing. Okay, so from here we need to say the time longer. Then you must say why the time become longer, then will stop to swing. So the answer is pendulum will take some time to stop as the switch is open and also you close. Okay, reason is inertia. They cannot immediately to stop. Okay, some more you using the power supply, you provide the energy. That's a big enough to make the bulb to be swing. If I never off, I still continue to switch on. You find out the bulb will continue to swing with the constant angle. Okay, constant angle. So that means when I just off the switch, you find it when starting still constant angle. Then the angle becomes smaller, smaller and smaller. So if I'm using the hand to swing, they cannot produce a constant angle. The second round they already smaller angle, third round smaller some more. So that means if I'm using the switch to open and close, I find it the pendulum we're using the time to stop should be longer. Okay, then we continue with the question 18. Okay, let's see the 18, they show you the design of the generator. Okay, let's see this one generator. We're using strip rings. Okay, we never using the battery. So I'm using the strip rings, so understood. Strip rings must be AC. Okay, they produce is an AC current. Okay, now name the principle we used in this one generator. So the principle we use is follow this topic name. There's an electromagnetic induction. Okay, let's see the B. They call you to mark. Mark the direction of the current. They flow in the WX and also YZ. Okay, YZ is the outside. WX is the inside. They want you to label the current, how to flow internal and external. When the side WX, then they tell you WX, the side of the coil, is displayed in downwards. Okay, the coil is displayed in downwards means they go downwards. WX go downwards mean another side must be upwards. So this one situation is a anti-clockwise. So we label first. We label the direction first. Okay, WX go down, another side is up. So this one situation is anti-clockwise. So now we're using our Fleming right hand rule. Okay, north, you point north to south. Okay, now we go an easier one. You see the, okay, we just label the WX lah. WX is the second finger. We do know there's a current, we keep it. Okay, you take out your thumb. Thumb is represent the motion. Now I want you to turn your thumb is go to downwards. Go to the downwards. Okay, when you go to the downwards, now you take out your second finger. Now your second finger, you point yourself. You point to yourself. Point to yourself means the WX. The current is from the W, go to the X. Because you point yourself, is it? So that means the arrow must be go to your direction. Okay, now we go to label the current. Okay, so W go to X. So another side must be opposite direction. Okay, now what you think about YZ? Okay, external. So when you W go to X, okay, must be come out for the first ring. Then they must go to the Y, then go to the Z. Okay, now I label the current in the YZ. Okay, they should be from the Y, go to galvanometer, then go to the Z. Then the Z join with the second link, then go in, go and another coin part. Okay, so this one is how you go to label the arrow. Okay, now you need to draw the graph to show the variation with the time of the current in the conductor YZ. So this one is a AC or DC. when you see the strip rings, sure is a AC. So AC, how to plot the graph, must be up and down. So we're going to show the graph up and also the down. Okay, you need to plot all the thing here, up and down. Okay, next, what happened to the current flow in the conductor was that when the speed of rotation increase. So that means you rotate the coin faster. What you think about the current? The current should be increased. That's a directly proportional. So your answer is current also increase. Okay, so this one is the tutorial I want to show you. So everyone, we are finished the tutorial 3.3. I think the structure just a short question. You also can be answer. If still cannot understand, that means you can PM me. I will explain for you the question. So the coming soon, I will post about the 5.4 lah, because I need to finish the chapter 5. Okay, after finish the chapter 5, then we continue with the chapter 3. So that means maybe we just left one of the topics lah. There's a chapter 4. Okay, so hope you study in your home. Okay, you see you soon again. Thank you everyone.